Good afternoon. Today we will discuss about friction, its concept, type and applications. So first we will talk about what is friction. So friction is a force between two surfaces that are sliding or trying to slide across one another. For example, when we try to push a car along a floor, and friction always works in the direction opposite from the direction of the object is moving. So if the object is moving along the right side, then friction direction is along the left side. It always slows down a moving object because it is a dissipative force, so it degrades the energy of a body. So like if a person is moving in the right direction, so the force of friction is opposite to the motion of the body. So force of friction to be in left direction, it is opposite to the motion of the body. Next, amount of friction, it depends on materials from which the two surfaces are made. So for different material there is different amount of friction depending upon roughness or smoothness. So the rougher the surface, the more friction it produces. For example, you would have to push a book harder to get it moving on a carpet than you would on a wooden floor. This is because there is more friction between the carpet and the book than there is less friction in the wood and book. So friction depends upon the two surfaces like book or any wooden or any carpet. Between the carpet and book there is more friction because the carpet is rough as compared to wood and book because wood is smooth than as compared to the carpet. So next is friction. It also produces heat. For example, if we rub our hands together quickly, they get warmer. So if we rub our hand, then our mechanical energy, it converts into heat energy. So with the help of friction, we convert our mechanical energy into heat energy. So we get warmer, our hands get warmer upon rubbing. Friction is not always a dissipative force. It can be useful force because it prevents our shoes slipping on a pavement when we walk and stops car tires skidding on the roads. So we cannot walk or we cannot ride a car without the help of friction. So friction is very useful force. Ice causes very little friction because it is very smooth, which is why it is easy to slip over an icy day, but this is good thing for ice skating and sledging because they require less friction as compared to the if we want to move on the ice. Sometimes we want to reduce the friction, like if we want to walk on ice, then there should be less friction. And another example is, for example, moving parts inside a car engine, they are lubricated with oil because to reduce friction between them. The oil holds the surface apart and can flow between them. The reduced friction means there is less wear on the metal and less heat is produced. So, the energy is less dissipated in this case. So, in this case we require less friction. So, hence the less energy is dissipated in this manner. Next is frictional force. When an object is in contact with the surface, then there is a force acting on that object. The component of this force that is parallel to the surface is called frictional force. Like these are two surfaces which are in contact with each other. So, the force which is parallel to this line is called frictional force. This is the resistive force. Resistive means it is opposite to the motion, it is opposing the motion. This resistive force is exerted on a moving object due to viscosity or other type of frictional property of the medium like air friction or the surface on which the object moves. Like I have already taken this example, if these are two surfaces and they are in contact with each other, and then there is some force acting between these two contacts like microscopic contacts, then this force of friction is in opposite direction to the motion. Force of friction, like if a body with mass m, then its weight is vertically downward in this direction Fw, and the normal reaction exerted by earth, it is in upward direction Fn, normal reaction, and this is the direction in which the body is moving. So, if the body is moving in this direction, then force of friction to be in opposite direction, then force of friction to be in this direction. So, this is free body diagram including friction, including the force acting on a body. There are four type of forces which are acting on a body. Its weight, normal reaction, the force with which the body is moving, and the force of friction. So, force of friction, it is exerted by a surface to resist the motion of the object because it is in opposite direction to the motion. Friction is always parallel to the surface and it acts in the opposite direction to the object motion. So, we already explained this thing, that if the object is moving in this direction, then the force of friction to be in opposite direction but along the same line, and the symbol of the force of friction is F small f. Friction, whether it is good or bad, sometimes friction is a problem, but sometimes friction is necessary. So, it is friend as well as foe. A sky put wax on the skies to reduce friction between the skies and snow to avoid any accident, and another one is, this one is biological application. So, this fluid helps to reduce friction between the moving bones in the joints of the human body. Sometimes friction is necessary, that a car that is starting to move, it requires friction, and if we want to walk or run, it depends upon totally on friction. If there is less friction, then it is very difficult to walk or run. If there is more friction than required, then it is also difficult, but if there is sufficient friction, then a person can easily walk or run on any surface. So, friction is problem as well as it is a necessary thing depending upon what type of situation we are facing. Next, friction is mainly friction types. So, friction is the force acting over the area of contact between two surfaces in the direction opposite to the motion. So, there are mainly two types of friction, static friction and kinematic friction. If we define types of friction broadly, then we can say there are three types: static, kinematic, kinetic, and third type is limiting friction. We will discuss in detail in the next slides. So, first one is static friction. As its name, static means rest. So, if when the two surfaces they are not sliding across one another, that is they are rest with respect to each other, then the friction which is in this situation is called static friction. So, the resistive force exerted on the object up to the time just before the object starts moving. So, we take example like this. In the figure A, if we apply some force in this direction and force of friction to be in opposite direction, if the body is not moving, like it is very heavy body and we are applying less force, then this time the friction which is acting in this portion, this is called static friction. And if we increase this force as compared to this force in the part A, then static friction also increases because it stops its motion. But if we increase the force again and again, then the body starts moving, then the maximum force of friction is Fs maximum, when the movement just begins, when the body just start to begin. So, in these three types, in these three situations, there is some force of friction which is acting, that is called static friction, because body is not moving. If the body starts moving, then dynamic friction comes into play. So, here some points regarding the static friction. The force exerted on a stationary object, that is at rest, by a surface that prevents the object from starting to move. So, force of friction, this static friction, the object remains at rest because the static friction is equal in magnitude and opposite in direction to the applied force. If this force of friction is same as the applied force but in opposite direction, then according to Newton's third law, these two forces are equal and opposite. So, the net force acting on a body is 0. So, object remains at rest. For the object just to move, the applied force must overcome the maximum amount of static friction. So, if this force of friction is less as compared to the applied force, then the body or the object, it starts moving. Second type of force is kinetic or dynamic friction. As from its name, dynamic means if it is in motion. So, the force exerted on a moving object by a surface, that is called kinetic or dynamic friction. It is denoted by Fk, and the direction is opposite to the motion of the body. If body is moving along the right direction, then force of friction to be in opposite direction along the left side. If the applied force is equal in magnitude to the force of friction, then the object will move with constant velocity. But if the applied force increases, then the object will accelerate, and vice versa. If applied force decreases, then the object will deaccelerate, that is its velocity decreases. There are three types of kinetic friction, like sliding friction, rolling friction, fluid friction, or air resistance. We can define broadly in three types. Also there are like viscous friction. So the sliding friction is an object is scraping or sliding across a surface. If two surfaces they are sliding across each other, then the force of friction which comes into play is called sliding friction. Second is rolling friction. An object rolls across a surface, like the tires are moving on the surface. So that type of friction is called rolling friction. Fluid friction or air resistance. An object travels through water or air and experiences drag, some friction. Drag means friction in opposite direction to the motion. Now we will discuss the coefficient of friction. It is very important term. So coefficient of friction, it is the ratio of force of friction to the normal force. Force of friction is in opposite direction to the motion. Normal force, it is exerted by earth to a body, and it is in opposite direction to the weight of the body. Symbol for the coefficient of friction is mu. It is Greek symbol, and it is defined as the ratio of force of friction to the normal reaction. The coefficient of friction has no units because this is also force and this is also force. So force upon force has no units. So coefficient of friction has no units or direction, since it is a ratio of these two forces. Next, the coefficient of friction, it depends only on the type of material and can only be determined experimentally. We cannot measure this mu by theoretically. It can only be measured by experimentally, how the ratio of these two forces are there. For almost all the situations, the force required to start an object moving is greater than the force required to keep it moving at a constant velocity. So static friction is always more as compared to the dynamic friction, because the body is moving. If it is moving, then friction is less as compared to the rest position. This point is important, like if a body is moving as compared to it is in rest, then the force of friction while it is moving is less as compared to the static friction. There are two types of coefficient of friction, like coefficient of static friction and coefficient of dynamic friction or kinetic friction. Static friction, it is denoted by mu s, and kinetic friction, it is denoted by mu k. So now we will define mu s and mu k. Like this is free body diagram of a body. The mass, if the center of mass is at this point, then the direction of the weight is in this direction, in the downward, and normal direction it is in upward direction. It is always perpendicular to the surface. If the force applied on a body is in this direction, then force of friction to be in opposite direction, in this direction. So these two forces F and Fs, they are in opposite direction. because this is a force which we are applying and this is a force which is produced by a body. This is called frictional force. The force of static friction keeps a stationary object at rest. Fs is equal to Fn into mu s. Fs is static friction, Fn is normal reaction and mu s is coefficient of static friction. So, we can easily determine mu s from this formula. Fs is equal to Fn into mu s, where Fs is static friction, force static friction, Fn is normal reaction which is exerted by earth and mu s is coefficient of static friction. Now, we will define the coefficient of kinetic friction. If the body is moving, if the body is in motion, similarly the weight is acting vertically downward in this direction and normal direction exerted by earth is in upward direction. If the body is moving in this direction, then the force applied is in this direction. So, the force of friction which is produced by these two surfaces is in opposite direction to this right side. So, force of friction to be in left side. This is the direction of kinetic friction. So, similarly we define, once the force of static friction is overcome, then the force of kinetic friction is what slows down a moving object. So, the meaning of these lines is that first the body is at rest, then the force of friction which comes into play is static friction. If the body starts moving, then the instead of static friction there comes Fk, kinetic friction. So, Fk is equal to Fn into mu k. Fk is force of friction which is when the body is in motion, that is kinetic friction. Fn is normal reaction which is exerted by earth on a body and mu k is coefficient of kinetic friction. Static friction, it opposes the impending relative motion between the two objects. Friction always opposes. The kinetic friction, it opposes the relative sliding motion that is happening between the two surfaces. It is the resistive forces exerted on an object during its movement. And kinetic friction, it is normally much smaller than the static friction. We already discussed this formula, Fk is equal to mu k into Fn. Mu k is always lies between 0 and 1 and it is called coefficient of kinetic friction. And can you please guess what is the direction of frictional forces? It is in opposite direction to the motion, opposite direction to the movement of the body. Value of the friction can be calculated using the coefficient of friction mu, which depends on the material of the object and surface. F is mu into Fn, where Fn is normal friction, and static friction formula is Fs or static friction, Fs is equal to mu into n, while the kinetic friction formula is Fk is equal to mu into n. This is a pictorial definition of like how the forces are decreasing. If we increase the applied force, then the force of friction, it continues to increase up to this point, up to the motion. If the body is at rest up to this point, then the force which comes into play up to this point is called static friction. Then at this point, force of friction decreases. This time is called limiting friction. Force here the friction which is acting is called limiting friction. After that, if the body starts moving, then this friction is called dynamic friction. I will repeat this point. If the applied force increases, this is a graph of applied force with respect to frictional force. If we increase the applied force which is acting on a body, then the static friction comes into play first because the body is not moving. So, from this point to this point, the force of friction which is acting is called static friction. Then the force of friction decreases instantaneously, then this time is called the limiting friction. Up to this point and afterwards the body starts moving, then the friction comes into play is called dynamic friction. At some point the pulling force will be greater, and so that the friction force cannot prevent movement. So, at this point frictional forces cannot stop the movement of a body. So, body starts moving from this point onwards. So, here the force of friction which comes into play is called dynamic or kinetic friction. So, this formula we already discussed. Mu s is equal to F maximum upon F normal. Mu s is coefficient of static friction, F normal is normal force, F maximum is maximum static frictional force. It is a dimensionless quantity as well as unitless, and it is unaffected by the mass of the object or the contact area or the surface of the two bodies. The greater the magnitude of mu s, the greater the force necessary to move the object. This is just repetition of the previous thing. As the block moves along a table, there still a frictional force that resists motion while the two bodies are sliding across each other. Then also there is some forces which is acting on a body, force of friction, that is called dynamic friction. So, mu d is equal to F frictional, that is this is dynamic friction divided by normal reaction. So, mu d is coefficient of dynamic friction, n is this Fn is normal force, F friction is force resisting motion, that is dynamic friction. It has been found experimentally that mu d is always less than mu s. Dynamic friction coefficient is always less than static friction coefficient. Mu d depends upon the relative speed of the surface. So, mu d is totally depend upon the speed of the surface. As the speed increases from 1 centimeter per second to 1 meter per second, mu d is approximately constant. Now, we will discuss about the applications of the frictional forces. The physics of car tires. The magnitude of the static friction acting on a rubber tire on a road surface, it depends upon the coefficient of friction and the surface area of the contact. We know race car tires have no threads, so races are sometimes postponed due to rain because there is no friction without threads. Race cars use wide tires to increase the surface area to prevent slipping through curves. This is also another example to how we can provide friction between the tires and the surface and the earth. On the wet roads, traveling at low safe speed allows time for the water to move through grooves. If the driver speeds up, the water starts to build up in the front of tire, causing the tire to lose contact with the road.